The Pearson correlation measures the degree of linear relationship between two variables when the data, x and y values, consist of numerical scores from an interval or ratio scale of measurement. However, other correlations have been developed for nonlinear relationships and for other types of data. There are three additional correlations: the Spearman correlation, the Point-Biserial correlation, and the Phi-Coefficient. The graph on the slide is taken from figure 14.11, shown on page 473 in your text, and shows the typical relationship between practice and performance. For nearly any skill, increasing amounts of practice tend to be associated with improvements in performance. The more you practice, the better you get. However, it is not a straight line relationship. When you are first learning a new skill, practice produces large improvements in performance. After you have been performing a skill for several years, however, additional practice produces only minor changes in performance. Although there is a consistent relationship between the amount of practice and the quality of performance, it is clearly not linear. If the Pearson correlation were computed for these data, it would not produce a correlation because the data do not fit perfectly in a straight line. In a situation like this, the Spearman correlation can be used. Spearman would also be used if you have collected your data using an ordinal measurement system. The second alternative to the PearsonR formula is the Point-Biserial correlation formula. When you have gathered your data on one of your variables using an interval or ratio measurement system, described on the slide as regular numerical scores, but you've gathered the data on the other variable using a dichotomous scale, the correct test statistic to use is the Point-Biserial formula. Examples of a dichotomous scale might be true-false, or yes-no questions, or male-female. An example of a dichotomous scale could also be a multiple-choice question, because you have one correct answer and all the other answers are incorrect. The final alternative to the PearsonR formula that one might choose, depending upon the measurement system that was used to gather data for your x and y variables, is the Phi-Coefficient correlation formula. This formula would be the correct choice if the data for the x and y variables were gathered using a dichotomous measurement system for both variables.